Hi everyone, welcome to another Learning at Lambert Labs session. Today's presenter is Ramin, so I'll hand over to you, Ramin.
Thanks, Tom. So today we'll be looking at HTML5 videos on the web. And of course, a lot of different companies have invested heavily into videos on the web. So we'd like to see the kinds of different techniques that they use just to achieve different kinds of experiences for the end user. So for example, we have YouTube, which was the first one. It's just video sharing, really. Then we have Zoom, which is completely different. It's video conferencing. The technology underneath it is completely different. We have Twitch, which is live streaming. Again, a different challenge. And then Instagram and TikTok actually provide interactive experiences where they're able to change the video on the fly, provide filters, allow users to, for example, like the video and then hearts appear across the video, or even green screens, and all that other sort of stuff. And we'll be mainly focusing just on the video element in HTML5. We won't be focusing on things like WebGL or virtual reality or anything like that. So let's just begin with the basics. So the basics are, of course, everyone knows this. You have a video tag, you provide a source attribute, and then that source attribute is a video.mp4 file. Now, the question is, why does that have to be an MP4 file? Why can't it be anything else? Well, an MP4 file isn't actually a video format, it's a video container format. So what that means is you actually have your real video and your real audio packaged together within the MP4 container, and there's some additional metadata involved. And let's just have a look at what that looks like. So here, for example, I have a video.mp4 file, and I can just use something called ffprobe, which is a function that allows us to inspect this MP4 file. I'll just zoom in, and I can just type video.mp4, and it gives us all the information that we need. So we see here that there's metadata, then there is a video stream, and then there is an audio stream as well. And the video and audio stream are characterized by compression algorithms. So for example, here we have a compression algorithm. Then we have how the pixels are formatted, the ratio of the screen size, the bit rate, the frames per second, etc., etc. We can use ffprobe even to see individual frames, what they look like, and so on. But the main gist of it is that MP4 is the default choice for the web, just because it has excellent compressions without sacrificing quality. So you have a good, a kind of good video that you can look at, while it's quite lightweight, so it's able to be transferred over HTTP. Because of course you might have a mobile network where you can't transfer a lot of data, and something like a .mov file, .avi file, it would just take up too much space, which is why we've settled on MP4. Of course, you also have things like WebM file formats, and we can actually convert our MP4 file into a WebM file just by typing input video.mp4, and then our output we'll just call WebM. Actually, let's just call it video.webm. All right, you'll see that we now have a video.webm file. We can also inspect that once it's completed. And see that in fact the WebM file will be a little larger than the MP4 file because it's not as optimized. Now both of them work on the web, although WebM files only work on Chrome because of course it's Google that is championing them right now. And this is taking quite a bit longer than expected, although I won't be needing the WebM file anyway, so I could just go ahead and cancel this if I want. Okay. Now, we talked about just having a basic source attribute, but of course HTML5 provides us a lot more options. So for example, we can have a video element, then we can specify that we want native controls. What this does is it gives us functionality to play, pause, fast forward, etc. Then we can specify individual source tracks. So what we've done here is specified first video.webm, and if the browser can't find a video webm, or if it can't understand what webm is, it will just skip on to the next one. And in this way, lots of websites were saved in the 2020 apocalypse of Flash, for example, because they would have, first of all, a Flash version of the video, but then also an MP4 version of the video. And if Flash isn't recognized, it defaults to MP4. If MP4 isn't recognized, it defaults to Flash. Then we also have track. And this is something that's a work in progress for HTML5. In the future, they also want to provide things like sign language and also narrations. But right now we only have subtitles. So the way you can actually introduce subtitles into your video is through a VTT file. So that's just text. And we specify, first of all, the time that we want the text to start, the time that we want it to end, and then we just write some basic text. So I wrote this subtitle file. It's really easy to write. And this will just natively appear within your HTML5 videos. And we can actually look at an example of that over here. So here we have just a video that I embedded. We can look at the DevTools. We just have a video. We have source track. And if I play this video, you'll see the subtitles that I wrote earlier just playing. So what is the downside of this kind of notation that I've been using so far? Well, you see here, the video was loaded as one big chunk. So if I go into the network panel and I just refresh the page so that works, you'll see that video.webm was loaded because it was found. And it was loaded in one big chunk. So what that means is if someone only watched halfway through the video, they still had to load the full video. If they saw half of the video in Spanish, let's say, and then they wanted to switch over to the English version, they'd already loaded in most of the Spanish version. So that's a lot of wasted bandwidth. So what we want to actually do instead is use something called streaming. And what streaming would do is instead of loading the entire video, load it in chunks. So that we wouldn't have to go through this entire process here. But before we look at that, let's just think about other ways of modifying the video. So you might have heard of Canvas. Canvas is, of course, another HTML element which allows you to just have full control of a drawing context on your page so that you're able to animate it and control every single pixel. So if we look at Instagram, which I mentioned earlier, they have something called filters. And with filters, you can actually change images and also videos to look the way you want. You can make them brighter, you can make them grayscale. Let's go with the grayscale example. So here what I've done is I've just specified a canvas element. I've taken in the HTML, I've introduced a canvas element. And if the browser doesn't support canvas, I have this backup text for it. And then all I do is I read in the video data. So I also have a video playing, the same video that we had before. I take the data pixel-wise, and I just average out the red, green, and blue intensities of each pixel. And what that does, of course, is grayscales it. And if we look at the example now within our browser, we can see that on the left, we have the video. On the right, we don't have a video, we have a canvas element. So this is a different way of actually displaying a video. Maybe you don't want your users to be able to go right-click, download, or whatever. So instead, what we have is a canvas element, and when we play this, it gets the data gets transported onto the right-hand side. And instead of being the normal video, it's a grayscale version of the video. Now you'll notice that the subtitles have been lost. So there is some benefits as well as costs with this. But that's just one way to actually edit videos within the browser itself. So with this, you can affect things. You can achieve things like chroma keying, which you previously have to do on the back end. You can do all of that now on the front end. So I promised we would look at streaming. So if we go to YouTube, how do they actually implement a video tag? So first of all, I can't even right-click to go into the video tag. I have to manually search for it. So the way that I would do this is just go document.query selector, and then I go video. We would see that there's a video here, but you would notice that there actually isn't any source attribute. So if I try to actually go here and try to find it, we again won't find a source attribute the way you normally would. Instead, what we see is this. So this isn't a source attribute like we previously thought, because this is not an MP4 format. I'm assuming you can see this. So what this is a blob URL. So what's a blob URL? Well, we don't actually have a file here. Instead, we have a pointer in memory to some kind of data being stored in RAM. So that's what a blob URL is. It's just an object URL, and it points to some data that has been stored in RAM. So why would you do this? Well, we can actually inspect all the different blob URLs. within your browser by going to Chrome blob internals. This is, of course, browser dependent. And what we see here is a bunch of blob objects, and they're all being stored in RAM, but they're also being released. So if I refresh, it's constantly changing because RAM is, of course, volatile, and these keep going into RAM and out of RAM. And we can also see the length of the data as well as the data format. So these are mostly images, but there might also be videos amongst them. And the point of a blob URL is to load in different chunks of your complete video, because as you can see here, it's only loaded up to here, right? You can see this bar. It hasn't loaded the entire video like it would if we just used MP4 file format. And that's because it's smart. It realizes we don't need this yet. But if I click over here, eventually what will happen is the bar will catch up, and then it'll play the rest of the video. It will load it in dynamically. So we can actually see this in the network tab. We go into the network tab. We can see here we have video playbacks, and they're all being loaded asynchronously, which is what this XHR stands for. So here we have a bit of the video being loaded in, then we have some more of the video being loaded in, and so on. So the question is, how do you actually achieve this kind of effect within your own JavaScript implementation? And the answer is you use something called streaming. So we use something called media source extensions within JavaScript. And what we do here is we create a media source object. And then we take that. So what a media source object is it just allows you to store videos or images within it, as well as any kind of file data. And then we create an object URL. So this is the blob URL that we saw previously. We create a pointer to this in memory. And then we add an event listener so that whenever this is available, we can just push data into it. And I've done that just with a basic video here. I haven't split the video up into different bits and then loaded them in asynchronously because the code would get very long if I did that. You also have to be very precise when doing that kind of stuff because you don't want different sub-videos overlapping with each other, different segments of the video. So I've only loaded in a single video here. And you can already see how complicated it is because first of all, I have to actually specify the MIME type of the video. Because we're using a lower level browser API here, we can't just tell it that it's an MP4 file. We have to specify exactly which codec it's using. So a codec is just short for compression decompression. So it tells you the exact algorithms that it needs to recover the actual video content within. That's not the only limitation. You actually need the video to also be fragmented, which means that the metadata within the MP4 file or the WebM file is evenly distributed throughout the video. It's not just stored in one location, like we saw in FFmpeg earlier. And once we've done all of this, we can load it in, and it will be associated with that blob URL. And we attach that to the video tag. And then we'll be able to see, just like we did with YouTube earlier, that we have a blob URL. So here I am with a video. I'm going to refresh this page, and hopefully this will work. So if I go inspect elements, we'll see there's a blob URL here instead of an actual URL. And this will be a pointer to the file. So if I go into the network now, I'm expecting to just see our old MP4 file. Yes, there we go. It's a video.mp4 file. But the difference now is that it doesn't show up in our source code. It only shows up over the network. And that's because first we stored it and we loaded it in dynamically in RAM, and then we stored it. Whereas previously we were just storing it in the code, and it would load the file as a whole. Whereas now we have more control. For example, we can load this in halfway through, and then decide to not load it in and load in a Spanish version of the same video or black and white version of the same video, and so on. So those are just the different ways that we can create things called object URLs. Now, the last thing that I'm just going to discuss is the fact that we're using the HTML5 video player. And of course, the controls here are browser dependent. So you might see, for example, here we have a few options. We have picture-in-picture option, which just reduces the size of the video, and a bunch of other things. But again, these are browser dependent, so we don't want to rely on them. So the solution to that is just to use an actual package that is an industry standard, and there are many of those. So for example, we have Shaka Player, but the one that I prefer is video.js. So video.js just gives you this. If it seems familiar, I'm pretty sure Dailymotion uses it. If not, there are lots of different big websites and big companies that use this kind of extension just to make it uniform across different browser experiences. So if we click on this, it just gives us a bunch of options. So for example, with subtitles, we can turn them off now. We still have the picture-in-picture effect, but now it's uniform across every single browser. So we don't have to rely on each individual browser implementing this kind of interface. This is all heavily customizable as well through CSS, which the default browser controls are not. Okay. So next, we might think about different use cases for streaming. So one of them is, of course, adaptive streaming. So this is a very simple use case. The idea behind this is, what if your user doesn't have enough bandwidth to watch your video? How do you deal with that? And especially if they're, let's say, walking through an urban area. So they might start off having great Wi-Fi, and then later on, they have really terrible connectivity. But they still want to watch your video. Let's say it's a live stream, and they want to be able to watch your video. So how do you do that? You can't just shut them off. You can't just pause the video. So a better solution is to just store multiple versions of the same video in different qualities. So one might be 140p, one might be 360p, one might be 1080p, and so on. And then what we do is we serve them different versions of the same video based on the bandwidth. So I've done that here. So if we go to our media source extensions like we did previously, we create an object URL, and then we load in different data into the object URL based on the current user's connection. So here I've taken navigator.connection.downlink, which of course is the download speed. It's a number that indicates it. I'm not quite sure how this is measured, but I do know the ranges that I want just based on testing, because I've tested it. So anything less than 2, I want to give a low version to. So by low, I mean a low quality version of the video. So that these users are still able to see our video, just not in the highest of qualities. And otherwise, we just serve them the default version. Again, I'm specifying the MIME types. You'll notice that the MIME types are different between the 2 different video versions, and that's because this one had to be compressed a little more, so a stronger compression algorithm had to be used, which is why this differs a little. And then once we've done that, the rest is, again, the same as before. So I'll just change this to low backup, just because that's the file name I've used here. And we can actually go to this video now, and I'm pretty sure this is the example 5. Yeah, so if I go here, playing the video as normal, the quality looks fine to me. But now I can actually go to DevTools, I can go to Network, I can implement fast 3G. Now it might be fast 3G, but it's still much worse than my Wi-Fi. So I'm expecting to see a lower video quality. Yeah, so we see that there's a lower video quality being served. So of course you can also do this just by changing the source attribute of the video. But the difference is you wouldn't be able to do it while the video is playing. So here what we can actually do is split up the video into very small chunks, and then at the end of a chunk we can check the bandwidth, and if the bandwidth has gone significantly down, the next chunk that we load will be of lower quality. And then we can override that, or let the user override all of that through the settings. So for example, they might say, don't show me lower quality videos, just show me the normal quality. So now the question is, how did I actually make this lower quality version of the video? Because it's not as simple as it might seem. So the way to do this is, let's see, we use the ffmpeg command as we did previously. And then I just type in the video that we want to downgrade into a lower version. Then we specify the bitrate. You might have remembered earlier in ffprobe, where we checked and specified a bitrate in probably in the tens of thousands. So I'm going to really downgrade that down to 1,000. And then I'm just going to specify the out format. So let's just say load MP4, and I'll just hit enter. And then I'll wait for this to complete. So the idea here is that I'm just reducing the bitrate of the video. It should be pretty simple, and we see that we have load on MP4. And if we were to look at this video, it would just be the video that we saw earlier, which was the lower quality version of the original. But there's a problem here, that if we actually use this video, it won't work. So if I just type load on MP4, I hit enter, this should not load. Yeah, it doesn't. the console won't give you any indication of why this is, and it's something that really bugged me for a long time. The documentation isn't clear on this either. And the reason it says true here is because I'm actually testing whether the MIME type is correct. You can see here, is MIME type supported? It's telling me yes, the MIME type is supported. So why isn't this working? Well, what we actually have to do is create a fragmented video. So what that means is, again, we're redistributing the metadata of the MP4 container. So there's some understanding of the theory behind videos involved in this. And the way we do that, especially for Chrome, is quite important. So we take FFmpeg, we enter our load.mp4 file, and then we have to give some flags just to specify how the metadata should be handled. So we go move flags, and then we write frag keyframe plus empty, and then move, and I'm just trying to remember this. Fragmented. Yeah, wait. I think it's this, and then we write fragmented.mp4. That should work. So now if I go here and I type fragmented.mp4, this will hopefully work. And if it doesn't, okay, there you go. Did that work? Is this the low quality version? No, it isn't. Let's change our network to far. Oh, it is network far. Okay. Well, maybe I didn't run the compression, the downgrade correctly earlier. But you see now that the video works, whereas before it didn't. And the reason for that was I had to set these additional flags to fragment the metadata around within the video container, which is quite peculiar, but it's one of the limitations of the media source extension right now. So instead of programming your own media source extensions, you should, again, just use a default player. And I'm again using the video.js player here. But the question is, how do you do general streaming? Because we can't just load in different chunks of videos. How do you actually get different chunks of videos and stitch them together? Well, the way that's done is using something called the manifest file. So if I go back to the slides, when we're doing streaming, we have to use a streaming protocol. And there are two big ones right now. There's HLS and Dash. So HLS is, of course, made by Apple. Dash is made by MPEG, the same people who created MP4. Indirectly speaking. So HLS stands for HTTP live streaming. Dash stands for dynamic adaptive streaming of HTTP, I hope. And we're going to go with HLS just because it's the one that I'm most familiar with. It's the one that I've seen most in the real world. And the kind of manifest file that they use is called an M3U8 file. So an M3U8 file is what we're going to generate now. And what that will do is just list all our different chunks of videos that we're going to stitch together to make our main video. And the process that we're going to use is going to involve FFmpeg, and it's also going to generate all the chunks of videos for us. So let's do that now. So I want to take video.mp4 and turn it into an M3U8 format. And we can do that really simply just by typing FFmpeg -i video.mp4, and then the output we're going to say video.m3u8. Hopefully this works. Okay, so you'll see that first of all we've created a video.m3u8 file here, and now we're creating .ts files. Now my text editor, of course, thinks these are TypeScript files. They're not. I think they stand for transport segments. If that's not correct, apologies. But what these are is just fragmented videos, and there are lots of chunks of them. And how to stitch them together is specified in the M3U8 file. So you'll see here it says the first chunk is video0.ts, and it's 3.08 seconds long. The second chunk is whatever, and it's this many seconds long, and so on. And then what a video player should be able to do using JavaScript and media source extensions and blob URLs, like I showed earlier, is be able to stitch these together into a coherent video. So we'll look at an example of that right now. So if I go here, I'm again using this the video.js extension, which all you have to do really for that is create a video element and then just call video.js on it. It's really easy. And here, instead of passing an MP4 file, I'm passing an M3U8 manifest file. You could do the same with a .mpd file if you were using the Dash protocol instead. Then I have to just specify that this is using the MPEG standard for HLS. And now if I go into our example here, I should be able to play this video perfectly fine. But if I inspect it, it's actually going to use a blob URL, as we can see here. So it's created a video element which uses a blob URL. And then if we inspect the network while the video is playing, we can go into video. We see that the video.ts files are all being loaded in. And the reason they're being loaded in is because the M3U8 file was loaded in. And the way that this was loaded in was, of course, through a bunch of blob URLs. So that's in general how streaming is done in the real world. Is you just generate a manifest file, then the manifest file describes how to stitch different videos together, and then your video player takes care of the rest. But now that finally brings us on to the real question, which is how do we do live streaming? Because of course we can have a single manifest file, that's all good, but what if we need to have infinite .ts files? Because a live stream, of course, is never ending, potentially, or at least it's ongoing. So there are TS files that we don't currently have. How does that work? Well, to create that, we need a special kind of server. So I created a special kind of server, which for which I used this Node.js extension, which is the Node Media Server. This isn't the best way to do this. In practice, when I've actually done this in the real world, I've used Nginx, but it's a really big hassle to actually set up Nginx for this. So I haven't done that for this example. I went with Node Media Server. The downside is Node Media Server has a lot of latency if it's not configured properly, and I didn't configure it properly. So you'll see around a 20-second gap, which isn't really live, but it's live enough. So the way we configure this is we create an RTMP endpoint, which just stands for real-time messaging protocol, which is default 1935 port. We specify the chunk size, the grouping of pictures cache, as well as just other properties that we want to have for this endpoint. Then we can also specify an HTTP endpoint, and then we can specify how FFmpeg should be integrated and used by the server. So in this case, I've said that I want to allow HLS, which is the protocol that we're using, which interacts with and creates the M3U8 files. So now that we have this, we can actually start this server. So if I remove this, and I just go to one back, and I want to run node 07 stream live.js. Oh no, I'm in the wrong I'm in the wrong directory. So I go node 07 stream live.js. I start our server. This is a Node Media Server. It's not a traditional web server. And now what we can do is direct streams at this. So what that means is we have a real-time messaging protocol server here. And we can, for example, send it a video, and it will treat the video as a stream. Or we can send it another real-time messaging protocol server, and the two will interact with each other and cross streams with each other. But the stream that I have readily accessible to me is, of course, my webcam. So what I could do is just write a very long command, which I can't memorize. So I'm just going to copy and paste it. Hopefully it's one of these two. And what we're going to do is essentially take FFmpeg, take dev video 0, well, this is just my webcam, and then point it at the RTMP server. So I've set up the server here. We're just going to point a webcam at it, and hopefully this will work. Okay. I'm not sure if this is working or isn't, but it looks like it is. So if I go into live, there we go. We have index0.ts, index1.ts. We have an M3U8 file as well. So now let's look at the M3U8 file and how it's being generated. So as you can see, as different TS files are being generated, the index.m3u8 file is also being updated. and we can see 0, 1, and 2. And because I've set it in the configuration to only have 3 .ts files at a time, you can see 0 got deleted. And now it's only 1, 2, 3. So anyone who joins the stream can't go back to 0. And then we have 2, 3, and 4, 3, 4, 5, and so on. So now this should be a live stream of me. The way we access this is by creating just a web page. And again, using video.js. We just give it an M3U8 endpoint, and this should hopefully work. Now, it will be delayed by around 20 seconds, I think, or 30 seconds. Yeah, so you can see me talking there, which is like I'm blowing my nose. Okay, great. But yeah, essentially that was delayed by 20 or 30 seconds. So it was a live stream of me, which doesn't seem special because it's on my own laptop. But that is how you live stream to the masses. So there's one little problem with this, which is we just had to create a real-time messaging protocol server. And that's a lot of data. We had to create all of these files. We're still creating them. I actually need to stop this. And we had to go through this entire process. And then we have to serve all of these over a CDN to various users. How can we do this in a much more efficient way? Because, for example, if we do video conferencing, if we wanted to create a Zoom call, this would be completely unsustainable. It would be impossible. So we actually need a better way to do this. And the better way is using something called WebRTC. So WebRTC is a peer-to-peer version of streaming, where we don't actually need a server to store all the video files in chunks. Instead, what we do is use something called WebSockets, which you hopefully all know about. And we take WebSockets, and we create a WebSocket connection between 2 users. Then we make them peers on a network. Now, what peers means is that we allow firewalls and other things to not restrict the communication between the 2 people. And so what that results in is you create 2 peers on a network using RTC peer connection, and then you take the video from one user, and you stream it to the other user, and you stream their data over to this person. So what that quickly looks like, I'm not going to go through much of the code because we're running short on time, is I can click start here, and there's me. Now this isn't special because it's on my own computer, but I'm going to call someone, and I'm going to call myself, which again is limited by the example. But there we are. So I've called myself, and that is a different peer on a network. And so what we're doing here essentially is bypassing the server. And it's just 2. Okay, I don't know why that's happening. I actually took this code from somewhere else and modified it. They were doing some funky stuff with it. I'm going to hang up now. Yeah. So what this is doing essentially is just bypassing the server. So nice applications of that are, of course, Zoom calls, like I mentioned earlier. But another nice application is using your own viewers of a live stream as a CDN, which is what this website does. So it's called cdnbuy.com. I stumbled on it a few months back. It's a really beautiful idea where, of course, a lot of people watch live streams simultaneously, especially if it's a sports broadcast or any other kind of thing, Twitch streaming or any other kind of scheduled event. So what you can do is, instead of loading all the data from your server, is you load your data, let's say, to this person and this person and this person. You create a peer network, and now you only have to share with one of them. And that person then shares it with the other 3 people. So this is another technology which allows things like Zoom calls to actually function. It's known as WebRTC, and it's the final sort of advancement within this HTML5 video tag journey that I was taking you on. I actually want to just go back to it just to show one thing, which is that if I inspect element on this, you won't be able to see a video tag, a source tag at all. And that's because we don't just have a source tag for HTML5 videos, we also have a source object. And if I, again, go into the console, I can go document.query selector, video, and then I can go source object. And we see that it's a media stream. As opposed to earlier, when we're using media source extensions, we now have a media stream, which completely bypasses the server. So those are 3 things that we can attach to a video tag. It's, first of all, just a file. Second of all, a media source extension. Third of all, a media stream. Which brings us to the end. So that's almost everything anyone should know about the video tag. Yeah, I'm open for any questions if you have them.
Yeah, thanks for that, Ramin. Just have one question. Could you just, you've probably mentioned it already, but could you explain the reason why we have a blob URL? Why don't we just use the, I mean, with the usual URL, you still load some memory, presumably. So what's the benefit of a blob URL?
The benefit of a blob URL is you have a pointer in memory, so you can dynamically load in different data and then just remove that whenever you need. So for example, someone can say, okay, I just want to check out the Chinese version of this video like you would on Netflix, and you only watch it for 2 seconds. So you want to load that into memory rather than actually bringing a whole file in. So you can only load in part of a file. And then when you don't need that, you just revoke it on the spot and it goes away.
Okay,
So
yeah.
it's essentially just a in-memory storage device.
Yeah, okay, fine. Yeah, so yeah, that's clear. Thanks.